Hello, year nines. How are you guys? Welcome to Mr. Chan's classroom again. So today, following of the previous videos, the introduction to coordinate geometry, we are actually learning how to find the distance between 2 points today. Okay, so the learning objective for today is by the end of these videos, you will be able to calculate the distance between two coordinates using the distance formula. The keywords are the distance, coordinates. Okay, so if you still don't know what coordinates is one of those. Okay, and x step and y step, which I will explain in a sec, over here, and the distance formula over here. So let's begin. If you still remember from last videos, we talk about what is Cartesian plan. So Cartesian plan is where you actually write all your coordinates, and from there you are able to it makes it easier for you to identify what coordinates of each of the points are. So still remember there are first quadrant, second quadrant, third quadrant, and fourth quadrants, yeah? And each of that allows each of the coordinates to be different due to this thing. Alright, or anything going to the right hand side from the origin on x-axis are going to be positive, and anything going to the left is going to be negative numbers. And for y, anything going up is going to be positive from the origin, and everything going down is going to be negative. Okay, so now that we got that over the line, we are going to teach you how to find coordinates, the distance between 2 points. So here we have A and B. So A here has a coordinates of 2 and 4. Okay, and B here has a coordinate of 7 and 1. Remember, both of these, that one represent the x coordinates and that one represent the y. You always start with x and then y, same as this. That is y. So how do you find the distance between the two? So first you're gonna have to identify what is the distance between 2 points. So the distance between 2 points are this. Let me see if I can make it a bit straighter. So the distance between 2 points are that. Okay, these are the two the distance. How do you find that? You can't technically go and count, okay, it is 1 grid or 2 grid, because 3, 4 grid, 5. Okay, you can't do that because there are some of the grids are actually smaller than the other, like that. Okay, so that is where you use your Pythagoras theorems. Okay, so if you have a closer look, you will realize this actually, if I put dots down here, what does that resemble? If I even put a 90-degree right here, there you go. Does that resemble a right angle triangle? Yes, it does. It does resemble right angle triangle. And the distance that you're trying to look for is actually the hypotenuse. okay, and the two of these are your shoulder length. Alright, surprise, surprise. It just kind of proves to you that Pythagoras theorem is everywhere. So we knew the formulas that in your many videos ago. The Pythagoras theorem actually has a formula of c squared equal to a squared plus b squared, and c squared here there is your hypotenuse, which in this case is your distance, okay, and distance square of the distance is equal to the square of the shoulder's length, both shoulder length square, and added together. Okay, so how much is the shoulder length? Like you were wondering, you must be wondering, what are the shoulder length here? So it's the what's the value? So that is when you can actually calculate your grid. So the grid for your x-axis is this. I'm gonna use a red color. So right here, one grid, 2 grid, for your x-axis 3 grid, 4 grid, 5 grid. So your grid for your on your x-axis, there are actually 5 of them, 5 grid, and on your y-axis, which is here, you have 1, 2, 3. You have 3. It actually took out 3 grid. I need to do a better job. So 3 grid. Okay, so now you know the two of the shoulder length, which are 3 and 5. You should be able to find out the hypotenuse, which is the distance, isn't it? So the distance here, square, equal to 3 square. It doesn't matter which one you use first, it's going to be the same anyway. So 3 square plus 5 square. Okay, so that will give you 3 square is 3 times 3 is 9, and 5 square is 25. Okay, so your distance square is 9 plus 25 is, what is it? It is 34. Okay, so 9 plus 25 is 34. So that is the square of it. So what is actually is the distance? That is when you need to square root them. Square root of 34. So you can leave it like that. If not, you can actually square root that. Square root of 34 will give you 5.83. Okay, so that is the distance between A and B. So that is how you find out the distance between 2 points using Pythagoras. Okay, so now move on to even more well-made formulas which utilize Pythagoras theorem. It just a bit different from this above. Okay, is this distance formula, the distance formula here. So if you look at the distance formula, we have d square, which is your distance square, I mean the short form of it, equal to x step square plus y step square. Your x step here is this. I will have to use a different color again. So let's pick pink. Okay, here you go. So your x step is the amount of step that has been covered on x-axis, which is this. There are 5 steps that has been covered, but on x-axis. On the other hand, for y, you have 3 steps has been covered, alright, because 3 grids. So to break it down even more, you can use these formulas, which is highly useful. You don't even need to count grids once you know these formulas. For this, you still need to count grids, how many grids has been covered. But for the formula below, it is like a further breakdown of these distant formulas. It is x2 minus x1 square bracket square plus y2 minus y1 bracket square. Okay, what does this? You must be asking, what are these x square and x1 or y2 and y1? Okay, remember there are there are actually x2, not x square, my bad. So this is actually a coordinates. Okay, so what that means is, if I'm gonna make it even more obvious, it looks like this: x1 y1 bracket x2 y2. So these two are referring to 2 coordinates, alright, which in this case are your if I'm gonna make it even simpler, is your A, which is 2 to 4, and B is 7 and 1. Okay, so your x1 is your 2, your y1 is your 4, and x2 is your 7, and y2 is your 1. Okay, so if I'm gonna move it, teach you how to work on this. If I'm gonna move this over here, so it will mean like this, which is D. Okay, it's gonna put it into perspective. So I'm gonna pick y1 as my A. Okay, so however, you need to remember that x2 has to minus the x1. Your question might be, how do I know which one is x1, which one is x2, or I mean which coordinate you use to be there? It doesn't matter. You can have B as your x1 y1, or you can have B as your y2 x2 y2. At the end, the result will be the same. I'm gonna prove you how I do this, how that is the case. So D equal to square root of brackets. So x2 here, I'm gonna use B as my x2, the 7, and then minus x1, which is 2. The 2 comes from the A, which is the x of the coordinates A, plus, remember the square, and then plus y1, y2 minus y1. So y1 here is 1, y2 here is 1 minus 4, and then bracket. So let's solve this. Equal square root of 7 minus 5 minus 2 is 5 square, plus 1 minus 4 is minus 3 square. So when you use calculator, you will know 5 square is 25, and minus 3 bracket minus 3 square is 9. Okay, remember, if you use calculator, make sure you put the bracket for the 3. Okay, there's a big difference if you do minus 3 square and bracket minus 3 square. Okay, one will give you minus 9 and the other one will give you 9, positive 9. So, and that is a heap, like a massive difference, and it could means you getting a right answer or wrong answer. So after that, you square root, you add 25 and 9 together, you get 34. See, it literally go back to that one. All right, so I'm gonna tell you that it doesn't matter if you use A or B as your x1, or the other one y1, or the other way around. I'm gonna prove you why that's the case. I'm gonna use that. So let's say if I swap them around, but make sure when you swap both of them. So I'm gonna make A my x2 and y2 now. So 2 minus 7 square plus 4 minus 1 square. So you get 2 minus 7 is minus 5 square plus 4 minus 1 is 3 square. So you are going to get 25 minus 5, bracket minus 5 square is 25 plus 9. So there you go. You are going to get the same answer regardless. Please leave in the comment below whether you understand what I'm doing, and even better if you could write in your notes. Make sure, I can't stress enough, please write notes and ask me any question. Okay, that is the only way to improve for both of us. So to sum up these videos, it's gone for 17 minutes. I think I should summarize the whole thing. So hopefully hopefully now you know how to find the distance, use the distance formula to calculate the distance. Okay, because as we know, if you're gonna calculate the grid, it takes a bit longer, especially down the track when the grid become bigger. It will take you forever to count. And remember that how to find the distance of two coordinates are actually based on Pythagoras theorem. Thank you for listening. Peace. See you later.